Hello and welcome to today's lesson. We're going to talk a little bit about dimensional analysis today. Um, Dimensional analysis at its core is a big scary phrase for a method that we can use to convert numbers. Right? So when we have 100 miles and we want to know how many inches that is, dimensional analysis is one process, one tool that we could use in order to solve that problem. Right? It is by no means the only way to convert numbers. Uh, it is not, the most intuitive and straightforward way to convert numbers, but in science, I personally believe that it is one of the best methods to use to convert numbers from one unit to another, or to solve certain types of problems, which is why we're gonna, spend some time looking at it. When we look at dimensional analysis, we look at conversion factors. And what a conversion factor is anytime you have an equality, right? So 1 meter equals 100 centimeters. Anytime you have two things that are equal like this can be made into a conversion factor by making it into a fraction and putting one above the other. It does not matter if you put 1 meter over 100 centimeters or 100 centimeters over 1 meter. All right, we're going to talk about, which way you set it up in a little bit, but the main thing is you need an equality, which can then be used to help you solve your problems. The neat thing about dimensional analysis and using these conversion factors is the fact that the top and the bottom, the numerator and the denominator here, are equal to each other. Right? 1 meter is the same as 100 centimeters. And when you put, a number over the same number, you get 1. Right? So when we have y over y, that's 1. X over x, that's 1. Pizza over pizza, that's 1. Right? So 1 meter over 100 centimeters, they're the same. So you actually get a conversion factor that is equal to 1. And then interesting thing about this, right, the important thing about this is that you have something here that will change units but not value. Right? Because let's say we have something that we're going to multiply by a conversion factor. Whatever you get at the end, multiplying something by 1 doesn't change the value, right? Multiplying something by 1 doesn't change the value, it's just going to change the units. And that's what we want, right? When you convert something from one unit to another, you don't want to make it bigger or smaller, you just want to change the units and see what the new units should be and how that changes for, centimeters to meters, etc. One of our important phrases when we decide which way to set up our conversion factors is what you want over what you have. And that'll make a little bit more sense when we do an example in a second. So, back in the olden times in farmland, people wouldn't spend money to buy things, they would instead trade. Right? I've got so many cows, I could really go for some bacon, and so they would trade cows for pigs. Or I've got, so many horses, and I could really use some wool, so they would trade horses for sheep. And so if I were someone in these olden times and I had 6 extra cows, and I wanted to figure out how many ducks I could get, right? I really want ducks. They quack and they make me happy. So I want to see how many ducks I can get for 6 cows. If I'm going to convert using, right, these equalities, 1 cow equals 4 pigs, 2 pigs equal 1 horse, 3 horses equals 12 sheep, 2 sheep equal 5 ducks, Right? I could, right? I don't need to use dimensional analysis to solve this problem. I could take 6 cows and do 4 different math problems and end up with some number of ducks. Right? That is totally possible, and that is a totally fine option. But when we look at dimensional analysis, I'm going to show you why this is a good method for doing conversions and solving problems like this. I'm starting with 6 cows. I want to figure out how many ducks I can get. So I want my final answer to be some number of ducks. Right? I want to know how many ducks I can get. So that means in between here and here, right along this line, I want to set up a bunch of conversion factors to help me translate my cows into ducks, to help me convert my cows into ducks. I know, the only thing I know about cows is that 1 cow is worth 4 pigs. And so I want to set up what I want over what I have. I have cows. So if I'm going to multiply this by a fraction, a conversion factor, I'm going to put 1 cow on the bottom and 4 pigs on the top. And this by itself is going to convert cows to pigs. But I don't want pigs. I want ducks. So I'm not done yet. I could solve here and say, well, 6 times 4 is 24, 24 pigs, and then do my next step. But every time you stop to do math, you give yourself an opportunity to make a mistake. And so what we're going to do is save all the math for the end. We're going to do all of our setup, and then go back at it and do the math all at once. Right? So this gives me pigs. I don't want pigs. I want ducks. So what do I know about pigs? I know that 2 pigs are equal to 1 horse. So here up top I have pigs. So I want those 2 pigs on the bottom, and I want 1 horse on the top. If I stopped and I solved this out, I've converted my cows to horses. But I don't want horses. I want ducks, so I gotta keep going. Horses can be transformed into sheep. I can trade 3 horses for 12 sheep. But I don't want sheep, I want ducks, so I need to do my last bit. 2 sheep is equal to 5 ducks. And now I've set up all of my math to equal ducks. So I can start solving this. And the way we're going to solve this out, we're going to do some simplification, just like we've always done in every math class. Like I said before, things that are equal to each other cancel out, and that includes units. So here, cows divided by cows, that cancels out. Pigs divided by pigs, that cancels out. Horses divided by horses, sheep divided by sheep. And these things cancel out. But that's not the only thing that cancels out. Our numbers cancel out as well. Right? 2 goes into 6 3 times. 3 goes into 3 1 time. 2 goes into 4 2 times. And now if I clean all this up, I have 2 times 12 times 5 divided by 1. And that's going to give me some number of ducks, because ducks is the only unit I have left. So when I solve this out, do this math, it gives me 120 ducks. I only did math once. I only did math at the very end when I simplified all this out. This is the only math I did. 2 times 12 times 5 divided by 1. It's the only math I did. There is so much less opportunity to mess up when you only have one place that you're doing the math in. Right? If I was trying to convert this every time, right? If I was doing this a different way and I wanted to just start from the beginning and solve it the way I would normally solve a problem like this. I would start by saying, well, I've got 6 cows. So 6 cows, 1 cow is 4 pigs, so 6 cows is 24 pigs. And then I would look at the next one. Well, 24 pigs, if 2 pigs is 1 horse, then that's 12 horses. 3 horses equals 12 sheep, so 12 horses. And then I need to stop and figure out how to solve this. Is 48 sheep. 2 sheep equal 5 ducks, and so that means 48 sheep would be 120 ducks. But each time you stop to do one of these problems out, you give yourself an opportunity to make a mistake. And if you come to the end, let's say you messed up here and you said 12 horses isn't 48 sheep, you said 12 horses is 36 sheep. And then you went to convert that at the end, and you would get a totally different number. And this isn't correct. But how do you know, right? You have to go back and check each and every one of your math problem pieces. Each and every one of these 4 conversions, you have to stop and double check to make sure that you didn't make a mistake there. Right? With dimensional analysis, it's all of your work is in one place, and you have the opportunity to check your work all at once. It's all in one straight line. It's all in one big fraction multiplication. And at the end of the day, you're really only doing one small piece of math. Right? For this second one, how many pigs can I get for 24 sheep? So I'm starting with 24 sheep. And I want to multiply this by some stuff to get my way down to pigs. So I know I can convert sheep to ducks, but that doesn't help me. Right? That doesn't get me any closer to pigs. Right? I can't do anything with ducks. But I can convert sheep to horses and then horses to pigs. So let's do that. I have sheep, so I want sheep on the bottom. 12 sheep over 3 horses, or under 3 horses. That gives me horses, but that doesn't give me pigs, so I need to do one more thing. I need to say, well, I've got horses for pigs. I have horses, so horses goes on the bottom, and 2 pigs would go on top. And this, when I solve this out, is going to give me pigs, which is what I'm trying to find. And so that is where I should stop. And I don't need to keep going. I know I can convert pigs to cows, but I don't want cows, I want pigs. So why would I convert them away? Just like before, we're going to simplify out. I've got sheep on the top, sheep on the bottom. I've got horses on the top, horses on the bottom. I've got 12 and 24, which is going to reduce myself down to 2. And now my math is 2 times 3 times 2 divided by 1. So my math is 12 pigs, because pigs is the only unit I have left. Right? Dimensional analysis, again, while it's not necessary, is helpful because it allows you to make all of this, right, all of this converting into one simple thing at the end. Right? And it's always going to work in a way that cancels out your units, right? You should be setting up your units in diagonals, right? Sheep and then sheep on the bottom, horses on top, and then horses on bottom. Right? Setting them up in a way like dominoes where you're going to cross these out until you get to the thing you want. Right? Another nice thing about dimensional analysis is that you don't need to know what these units are. Right? Here we've got Igdals, Ondonks, and Falkirs, which are just nonsense words that I made up. You don't need to know what these mean to do this conversion. Right? As long as you know what's equal to what, you can figure this out. And so I'm going to pause here, give you 10 seconds. If you need more time, pause the video. Alright, so if we want to solve this out, I have 3 Igdals, and I want to get to Falkirs. So I can convert Igdals to Ondonks, and then Ondonks to Falkirs. So if I have 3 Igdals, I can set up a conversion factor. Right? I have Igdals, so I want my Igdals on the bottom, and 1 Ondonk on top. Then I want to put 6 Ondonks and 4 Falkirs. And that'll end with Falkirs on top, which is where I want to end. So I can pause here to solve. Cross out. Cross out. Simplify. 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 We end up with 1 Falkir. Now, here's another one. If I want to binge on donuts, and I go out to the store and I buy 4 dozen donuts, and I want to convert that into singular donuts, which is the correct way to set up my conversion factor. If I have 4 dozen donuts, and I want to put one of these choices in this blank to end up with individual donuts, which is the correct piece for me to use here. So the answer here, if I want to get rid of dozens, right, if I want that to cross out and give me individual donuts, I want dozens on the bottom. So it's not going to be choice 2. So I can either have 12 donuts over 1 dozen or 1 donut over 12 dozen. And then it's just a matter of, well, which one of these is correct? Is 1 donut equal to 12 dozen? Or is 12 donuts equal to 1 dozen? It's choice 1 here because 12 of something is a dozen of something. So if I'm going to put this in, 12 donuts over 1 dozen, I'm going to get the donuts, or sorry, the dozens canceling out. 4 times 12 is going to give me 48 donuts, right, which is the correct conversion factor for me to use there. Any other one of these things that I plugged in here would not have given me 48 donuts, and if I asked you how many donuts is 4 dozen donuts, you know it's 48. Right? But this is the correct conversion factor to plug in there, which makes it the answer. And with that, we're going to stop here, and I will see you next time.